Okay, so let's look at this one here. So let the function on which Fowler intervals is f continuous. So on a piecewise, first of all, I want to make sure that each piece is continuous on its own, so I don't have to worry about looking. I just have to worry about the switch points. Sine's continuous everywhere. Cosine's continuous everywhere. Tangent is not continuous everywhere. It's got discontinuities. Cotangent is the same. So tangent is sine over cosine. So anywhere where cosine is 0, tangent tangent will be not continuous. So I have to watch out for that as well. So in addition to checking spots where tangent and cotangent are not continuous, I also have to worry about any switch points. So like at 0, I got to make sure it's continuous by checking sine, the limit from the left and the limit from the right. So let's get started here. If I look at this interval from negative pi over 2 to pi over 2, it's asking if this function is continuous over that interval. Negative pi over 2 starts on this interval here, x less than 0. Up until 0, I'm dealing with the sine function. At 0, it switches over to the cosine function and continues to be that function from pi over 2 to pi over 2. Since sine and cosine are continuous everywhere, the only spot we got to check is when we switch functions at 0. If the function's continuous there, then that looks like that'll be our answer. So the way I check for continuity is I want to show that the limit as x approaches 0 is equal to f of 0. So if I start with f of 0 is saying plug 0 into cosine, and I get 1. So f of 0 is 1. Now I want to check the limit. I'm going to check from the left, which means x is less than 0, because as I approach 0 from the left, I'm at numbers that are less than 0. So I can plug in 0 into sine, and that would represent my limit from the left here. So when I plug 0 into sine, I get the limit from the left is 0. And that already is not going to equal f of 0, because f of 0 we said was 1. But let's just continue with this limit thing. So let's check the limit from the right. These are now x values bigger than 0. If I plug 0 into cosine, I get 1. So the limit from the left is 0. The limit from the right is 1. Therefore, the limit does not exist. Therefore, the function is not continuous at 0. So this interval is out because 0 is in this interval and the function is not continuous at 0. Let's look at choice B, pi over 4 to pi. Pi over 4 is in this interval because it's bigger than 0 but less than 3 pi over 2, and so is pi. So this interval, pi over 4 to pi, is contained entirely in this interval. So it's going to be continuous if this function's continuous on this interval. It is. Cosine of x is continuous for all x. So B is going to be a correct choice. I don't have to worry about any switch points since this interval is contained entirely in here. So B is the correct answer choice.